And now we're going to instructional innovation and beyond with the Division of IT's Office of Instructional Technology and Innovation.
My name's Stephen Bromfield. I'm the director of MTS. Over here we have Milton Ron. He's the manager of the Digitized Lab here at FIU. Last year at EdIT, I actually debuted the Volumetric Capture Studio. And since then, we've been doing a lot of cool things. And I actually wanted Milton to come this year and show you what we've been up to since that time's passed. So, Milton, take it away.
Well, thank you, Stephen. And good morning, everyone. Well, as Stephen mentioned, my name is Milton Ron Arias. I am the Digitized Lab Manager here at the FIU. And today I am here to talk about our Digitized Lab, what we do, what's our mission, and what kind of technology we are working with, and how this technology has the potential to change the way we learn and conduct research. So our mission is digitized reality to create immersive experience that improve student outcomes and improve also our faculty research opportunities. And what we are doing here is we are bridging the physical FIU with the digital world. And we can do this only thanks to the amazing technology we use in our studio. And let me start mentioning the volumetric video capturing technology. And as Stephen mentioned also in the introduction, a year ago, Stephen was in this very same stage presenting the groundbreaking Lee coupling I-star volumetric video technology. So we have here in GL181, our studio. We have also another studio in BBC AC 100. So these studios has been allowing us to record videos in 3D, which also means that we are digitizing humans. We are creating digital human assets. So we are not only digitizing objects or modeling FIU buildings or digitizing documents, because we have a variety of scanners in our studio. But also, we are digitizing the main component in our community, which is the people, us, our faculty, our staff, our students, right? So we later process all these assets to be usable in video gaming platforms such as Unity, Unreal Engine, and later we create applications with these assets that are ideal for immersive experience. So finally, we can deploy these applications in AR, VR, or mixed reality.
Just keep.
So what I want to show you now is the metrology grade 3D scanner. So this device expands our possibilities of service to our community. And maybe you are thinking, you know, nowadays I can just download an application and scan an object with my phone, right? But if you're looking for precision or you are looking for an accurate representation of reality, this is the way to go. And let me tell you why. As you might know, a 3D model is made by a polygonal mesh, and the accuracy and detail of this object are based in the size of each polygon that create this polygonal mesh. So this scanner has 0.05 millimeters accuracy and can take 1.5 million measures per second. So here you have a reference. This is 1 inch. This is half of an inch. And this is 0.02 of an inch, which in unit metric corresponds, of course, 0.05 millimeters. We are talking about something smaller than a sugar grain. Not even half, I would say even a quarter of the size of a sugar grain. So this is an example. We've been scanning a lot of objects, but I wanted to show you this one because this is very special. This is a Civil War cannonball, right? And it's been with the same family over 160 years. No, 160 years, Civil War, right? 1861, yeah, 160 years. So we had a great opportunity to scan this object. As you can see in the top image, we have, I can tell you as a fact, because the software tells me we have 1.8 million of small polygons, triangles, that is taking every single detail and corner of this object. But let's see another real-world application. And for this one, we have an amazing guest with us. He is going to tell you how and why he used our digitized lab service. So with us is Dr. Mike Heithaus.
Thank you. Thanks so much, Milton, and it's nice to be here today so you can answer the question, what happens when Jell-O meets high tech? And I will go back a little bit and start the story on how I get there. Back in graduate school, not going to tell you how many years ago that was, just a couple. And I was working on bottlenose dolphins in Western Australia. And in my work, I was really interested in trying to figure out why they were spending time in different areas in these shallow waters or deeper waters. And I thought it was all about the food. Why wouldn't you, right? Buffet table. But it quickly became obvious these dolphins were not spending a lot of time during certain times of the year in the waters where there was tons of fish. And why would that be? As you wait for the time lag on the clicker. And you look at the dolphins here, what you see is that about 75% of these animals have bites and wounds on them from sharks. And so you see these bites there, and you can see kind of on this animal, this big semicircular bite. And these are scars from shark attacks. And when you look at that, you can obviously tell what kind of shark that was, right? I hope you say no. A few of my colleagues might say, oh yeah, I definitely know what that is. But that would be just guessing. And so what we've wanted to do for a lot of years is to try to figure out what types of sharks might be attacking these dolphins and how big those sharks are. Because if we can figure out that information, we can get a sense of how these dolphins are making decisions between, say, getting enough food and staying safe from sharks. For those of you who are mathematically inclined, the funny thing is the models that we use to do this are exactly the same, pretty much, that they use in figuring out how people play the stock market. Risk reward, it's all the same, whether you're a dolphin or a person making investment devices. But you need to know what the risk is in your investments and what sharks might be a risk to these animals. Now, in the place that I work in Australia, there are a few sharks that might be responsible. And as you start to look around the world, there are a few possible culprits. One of them is the bull shark. This is an animal that gets to be, they're kind of small here in the Atlantic Ocean, only about 9 feet long. But in Australia, they can get to 12, 13 feet or more. But then we also have tiger sharks. And these are big animals. These get to be 15 to 18 feet long. They're built for attacking large prey. You can see that mouth right at the end of the snout. So they can reach out and grab onto a dolphin or a sea turtle. And it turns out they have teeth that are curved and serrated, so they can actually cut straight through a sea turtle. Now, if you're a tiger shark and you've done that, you do have a problem. I know I'm digressing, but they've got a lot of time on the clock I got to burn. You've got that good turtle meat in you, but you also have what? Shell. Has everybody had time to digest their breakfast, by the way? Okay, just wanted to check before I say this, because tiger sharks have that all sorted out. They can digest the good parts, and then they can turn their stomach inside out through their mouth. Shell falls out, then they just slurp their stomach back down, and they're ready to go again. Pretty awesome. But a tiger shark that can eat a turtle, a bull shark tries to eat a turtle, it's going to break its teeth. What would the bites on a dolphin look like between these two different species? Well, I was thinking about this question, and I originally thought, at FIU we've got people who might be able to help me figure this out. So I called up our Global Forensics and Justice Center and asked if they could make me some Jell-O pads that were the same density as dolphin blubber and muscle. And so this resulted in these big pads that you see here. That's me. That's about a 2.6 meter long bull shark, so about 8 feet long. And so the idea was we would just go down and we would get bites from different sharks. My student, whose fins you can see in the corner, is there with a camera and a laser pointer, or 2 lasers 7.5 centimeters apart. So if we can get that laser on the shark when it's perpendicular, we can actually measure how long it is. So now we know what species this was, because we got a very good close look. We know how long it was because we've got the laser measurements on it. And then we have the bites on the pad that look something like, well, that's the GoPro on that. It's close. But hey, you've got a giant lollipop between you and the shark, so no problem. And that's what these pads look like. And you can actually see one here. This is what the pads look like. So you can see that nice bite. The bull shark actually bit this pad so fast, it got 2 bites through that pad before I could even pull it away. It's a little different with tiger sharks that, I was trying to keep this from being too long because this is tech, not biology. So I have a tiger shark bite here. I will tell you it was a little different getting these from tiger sharks because they have a little harder time getting through it. And so we were able to get those. And what we wanted to do then is to measure things about that bite to get a sense of what's going on. So we want to look at things like this area on the bite pad that is away from the bite itself. Do you have the shark making multiple bites, leaving scars so that you might see different rings on the bite? But then also to look at how the teeth are moving through the pad or the tissue. So what we did for this was to go to the volumetric studio to do some scans. Because one problem when you're using Jell-O is it melts. So we didn't really have a good sense that long term we'd be able to keep these alive in their correct size and form. So we needed to make sure that we were able to kind of have a digital record in perpetuity, or as long as my hard drive lasts. I don't use a Dell anymore, so it goes longer. And so this is the scan that we got of the pads. This actually we just got this one last week. And so in this bite, you can see just one bite from the shark there. But then we can zoom in. And in this case, the shark actually bit it. And then, that's the next slide. So here's another move. So these are the 3-dimensional objects, so you can move them around, scan them. We can take measurements from them, so we can actually look at the angle of the bite on it, so we can get a sense of shape. We can measure the width. This screen is not the best for seeing it, but you see these dark lines here. That's where the teeth trace through the tissue. So some things that you can see in this one, and if you come up later and look at the tiger shark one that's really different, the tiger shark, the teeth are swirling all over the place. It's not able to just go through, but the bull shark you can see has just gone through like a cleaver. You can see right here where the top teeth hit and the bottom teeth make and just snip it off just like scissors. And so what we can do is go in and measure what we call interdental distance. So what's the distance between each individual tooth? We can look at even at this minute scale and even see where each serration, the bump on each tooth, where that has traced through. In this particular bite pad, the shark grabbed it and then spit out the piece it had eaten. I guess it didn't like Jell-O, although we managed to grab it before it came back because it wanted it. So this is actually the chunk that came out of that same pad. So this one you can see a little bit better. You can see how much detail is captured in that scan and how useful that can be for not just having that digital record, but actually making those measurements and being able to make them repeatedly. Now, one problem of studying shark bites on bite pads are easy to take out into the field, but that could give you a very different view of how animals are interacting with the tissue of these animals when you have something that's as round as a dolphin. So I made a phone call to Global Forensics and Justice folks again, and I said, "Can you make me a Jell-O dolphin?" And after there was a long pause, the answer was, so you can see that 3D rotation, just how fine that detail is. And you can just, look at that, you can just see right where those teeth came in. And so I called them up, and a few days later, I had Gooey, the dolphin. You can see Gooey on the stage here with us, but you can also see very quickly from initial Gooey, dorsal fin was standing straight up. Sitting in my office for the last couple months, Gooey, and being on a boat for multiple days at a time, you can see why we want to have these scans. And so what we did is we got Gooey. We took Gooey out on the boat with us, a bunch of our PhD students. Dorsal fin is still upright. It turns out you have to treat Gooey as nicely as a real dolphin. Wet towels, fan it. And then we found out that the bull sharks of Florida are terrified of Gooey. Now, originally Gooey was supposed to go to the Bahamas to Tiger Beach, where it would have lasted probably about 0.3 of a second with tiger sharks. But we had to change plans, and so we had to dress Gooey up with a skirt of bonita, which is a fish that bull sharks love. And that helped us out a little bit. So there is Gooey floating in the water, looking very dolphin-like, and this is actually about the size of a nearly adult spotted dolphin. So this is life-size. And after 3 days of floating Gooey on and off, scaring the bull sharks, going, "What are you talking about? What is that thing?" We did finally manage to get this. And I'm scared to push the advance button again in case I miss the slide. We'll give it 5 seconds here, and then if not, yes. So this is what it looks. This is the tech conference, right? Okay, so, hey, look, there's a bonita here. And what happens after that is you get something like this. And I think we're going to be leaving Gooey around if anyone needs a selfie with it. The other reason that we digitize everything we do is everybody wants to touch, which changes things a bit. So this is what the bite looked like fresh out of the water. And you can see it here as well. And one of the things that we see from this immediately from the science part that is really interesting is that if you look at the bottom jaw, that bite is way narrower than the top jaw. And that is kind of surprising because in bull sharks, the jaws are exactly the same width. So for years, people, when they were trying to estimate the size of sharks, were like, "Oh, we just went to a museum and we measured the distance between the teeth and the width of the jaw. It's got to be this." Turns out that's not how shark jaws work. In the museum, you see dried jaws, and they've usually been pulled out really wide. They don't sit like that in the shark. And the jaw is not made up of an upper and lower cartilage. It's actually made up of 4, 2 on the top, 2 on the bottom. In the middle, that's connective tissue. So in a living shark, the jaw can kind of flex in and out. And so the way it hits a rounded object like the dolphin, it really changes how the bite is. So we got Gooey and took Gooey on a field trip from my office over to the volumetric field. And the cool thing is the video we'll show here actually appeared in the National Geographic and Disney Plus show Sharks versus Dolphins, which is still streaming if you want to see it. But this shows you that even a big, giant, three-dimensional object like Gooey can be scanned. And this is going to give us that ability to go in and really measure all the aspects of this bite. And you can just see how even a shark on a bite this big, those teeth pretty much just slide through once and then clamp off. And that's, 20 pounds of flesh or jello. The other nice thing with these scans is the way you can change color bands to be able to look at different bits of detail in those images. So you can see when you change the color there, it's a lot easier to see and then to measure how those teeth have moved through it. So, while it's super cool to have the animation, it also really is very important for us scientifically so we can make the measurements and have this record permanently, because who knows what I am seeing on this a couple years from now. A student might come back and say, hey, I wish we had this. By that time, even when I have the shades closed in the office and no direct sunlight, I can't guarantee the longevity of my Jello dolphin. So, that is just one kind of bizarre real-world application of the volumetric scanning capabilities, and it's one that we are hoping to continue to use, because so far we've just got lemon, bull shark, and tiger shark. We need to get a whole series of these from different size sharks from about 7 different species. So we'll be continuing this project and probably coming up with crazy new ways to use the facility. So I'm going to turn it now over to the experts again to answer any questions you've got. And then when they're done, I'm happy to stick around if you have any questions about sharks versus dolphins.
Thank you, Dr. Heithaus. So I'll tell you something. I'm not fond of public speaking, right? But given the option of swimming with sharks or being on stage, I'll be on stage. All right. So other than research, we can use the facility to do educational things, right? So as we were seeing with the keynote speaker, she was talking about in Coursera, one of the issues that she was having was engagement. We know that with engagement, student outcomes becomes better, right? So what we've seen with AR and VR applications, when students are immersed, they're more engaged. And also, with that engagement, they feel more confident in the coursework that they've learned in these applications. Which again improves student outcomes. So the scanner, the hand scanner that we have that was used to scan GUI, is perfectly usable in education, because then we can use that to bring down the cost of making models that are used in VR and AR. And as Milton was saying earlier, we have programmers on staff that can help out. Different utilities. We have the Volumetric Studio itself, which is a studio that you can do 3D models in video, basically. And we want to make sure that our team provides the support that faculty need to get these applications out and in the students' hands. So, there we go. To get a hold of us, right, you can email us. Preferred ways, ticket via Ask IT. But during lunch, we also have a table, and we have Javier in the back there in the nice suit. He dressed up for us. And you can come out and talk to us. There's some other applications that are directly educational that we can tell you about and kind of give you a demo. So that's it, folks. Thank you.
Fantastic. Thank you, OITI, for going beyond. If you have any questions for this team, they'll be around to connect with you throughout the conference.